now let's look at the first question. What has been given here? Let A vector is equals to this, B is equals to this, C is equals to this, where alpha and beta are integers and alpha beta is equals to minus 6. Let the values of ordered pair alpha beta for which the area of parallelogram of diagonals A vector plus B vector and B vector plus C vector. So in the question they have told us that there is a parallelogram and its diagonals are basically this and this. So this is my D1 and this is my D2. So, and they have told us about the area of parallelogram. So we had studied the formula of directly finding the area of parallelogram. It used to be half modulus of D1 vector cross D2 vector, and they've given us the area, which is this value. So we have to find out basically the values of alpha and beta and then whatever they've asked us. So first what we can do is let us find out the area using the formula that has been given to us. So it is going to be half of D1 vector cross D2 vector. What is our D1 vector? It is our A vector plus B vector. Let us find out what our A vector plus B vector is. This is our A vector and this is our B vector. So let us find out the A plus B. So from here what are we going to get? This would become 2 minus 1 becomes I cap plus alpha j cap plus 2k cap. Since we know there is no j cap component in B vector, so from the A vector alpha j cap remains as it is and it comes the way it is. Now let's find out D2 vector, which is our B vector plus C vector, and so this can be written as minus I cap plus beta j cap, and k cap gets cancelled from each other because the coefficient in B cap is plus 1 and the coefficient in B C vector is minus 1. So from there k cap gets cancelled out. So now let us find out the cross of these two. So we have to find out half modulus of basically this is 1 comma alpha comma 2 cross with minus 1 comma beta comma 0. Basically this is what we are trying to find out. I'm just representing my D1 vector in this format and D2 in this format just so that it becomes visually clear for us as to what we have to find. So this can be written as half of determinant of I cap, j cap, k cap, and this can be written as 1 alpha 2 minus 1 beta 0. So let us find out what do we get from here. We are going to get I cap times of minus 2 beta minus j cap times of 2 plus k cap times of beta plus alpha. So this is basically our area that we are getting. Now let us find out the magnitude of this area. So we would get half of root under 4 beta square plus 4 plus alpha plus beta whole square, and this value is equal to root 21 by 2 as it has been given to us in the question. So 2 and 2 gets cancelled from here, and let us square both these sides. So what do we get? We get 4 beta square plus 4 plus alpha plus beta whole square. This is equal to 21. Let us simplify this further and let us open this square bracket. We are going to get alpha square plus 5 beta square plus 2 alpha beta is equals to 17, and alpha beta, the value of alpha beta has been given to us in the equation. It is said that alpha beta is minus 6. So from here let us replace the value of alpha beta to be minus 6. So we get alpha square plus 5 beta square minus 12 is equals to 17, and from here we get alpha square plus 5 beta square is equals to 29. So this is first equation that we have gotten. Now what have they told us? We have to find out the values of ordered pair for alpha 1 and alpha 1, alpha 2, beta 1, beta 2. So basically this is one of the equations that we have. What is our another equation? Our another equation is alpha beta is equals to minus 6. So we have to find out by hit and trial method what are the values of alpha and beta that will satisfy both these equations. So again, this becomes a very lengthy process for us because we have to hit and trial each and everything. So firstly, let's look at the multiplication part. It is alpha into beta. So first of all, either alpha or beta, both of them either of them can be either 3 or 2, and one of them has to be negative value. Of course, we cannot take 6 and 1 because 6 and 1 wouldn't be able to satisfy this equation here. And beta, we will have to take it to be 2. So here we have gotten one thing, that the let's say modulus of beta is always going to be 2, and modulus of alpha is going to be 3. So this is the first thing that we've gotten. So from here, how many combinations are possible that would satisfy both these equations? So one pair that would satisfy is -3, 2, and the other pair that would satisfy is 3, -2. Apart from this, I do not think there are any other values that would satisfy this equation. So basically, we've gotten, by hit and trial method, we've gotten our values of alpha 1, beta 1, alpha 2, beta 2. So our alpha 1 becomes -3, alpha 2 becomes 3, beta 1 becomes 2, and beta 2 becomes -2. Now let us find out whatever had been asked to us in the question. That asks us to find out alpha 1 square plus beta 1 square minus alpha 2 beta 2. So what would this become? This would be 9 plus 4 plus 6. So this turns out to be 19. This is our answer. A very easy question that was asked. The only thing is that you had to know the formula of finding out the area of a parallelogram using the diagonals, if the diagonals of a parallelogram have been given. Let's look at another question. In this question, let A vector be this, B be this, and C be a vector such that they've given us an equation based on C. If this with dot product with C vector is equal to 1670, then we have to find out C vector modulus whole square. So first, let us try to simplify this equation that has been given to us and try to extract whatever values we can from this equation. So we've been given A vector plus B vector cross C vector is equals to C vector cross -2A vector plus 3B vector. So from here, what can we see is, let us first try to convert both these sides in the same format. That means in one side, if we have A cross B, then let us create the other side also A cross B. So how can we do that? We had studied this in our commutative property of cross product. This would remain as it is, cross C vector, and this would transform itself with a minus sign outside. -2A vector plus 3B vector cross C vector. I hope you all remember we had studied this, that A vector cross B vector is always equal to -B vector cross A vector. So that is what I have done here. Now if I multiply this minus inside, what am I going to get? A vector plus B vector cross C vector is equals to 2A vector minus 3B vector cross C vector. Now let me take this entire equation to the one side of the equation. So this would become A vector plus B vector cross C vector minus 2A vector minus 3B vector cross C vector. This is equal to 0. Now here you have to use the distributive property that we had studied. I hope you all remember we had studied, let's say if A cross B cross C has been present, or let's say any equation here has been present. Let's say A plus B cross C has been present. So we can say this is A cross C plus B cross C. So let us convert now our equation. We've converted it in this format. Now let us convert it in this format. So this would become A vector plus B vector minus 2A vector plus 3B vector. This would become cross C vector is equals to 0. Upon solving this, what do we get? Minus A vector plus 4B vector cross C vector is equals to 0. Now one thing, another properties again. Now we have to again look into properties. If we have A vector cross B vector is equals to 0, what does this imply? This tells us that A vector and B vector are parallel lines. I hope you all remember whenever the angle between A vector and B vector used to be 0 or 180, that time their cross product used to come out to be 0. I hope you all remember this. That means these two vectors here, this vector and C vector. These two are parallel amongst each other. And one more property of parallel vectors that we remember, if let's say two vectors are parallel, then I can say that A vector is equal to lambda times of B vector. So let us use this property here. So from here I can say that C vector can be equal to lambda times of minus A vector plus 4B vector, and lambda is my any scalar quantity that I'm talking about. So we've gotten this. Now let us look at the other equation that they've given us. They've given us that 2A vector plus 3B vector dot product with C vector is equals to 1670. Let us replace the value of C from this equation. So what would we get? 2A vector plus 3B vector dot product lambda times of minus A vector plus 4B vector. This is equal to 1670. And from here again scalar quantity can be taken outside. So here now let us take out the dot product. What are we going to get? Minus 2A vector modulus square plus 4 2s are 8 A vector dot B vector minus 3 A vector dot B vector plus 12 B vector modulus square. This is equal to 1670. Let us try to solve this further. What do we get? We are going to get minus 2A vector modulus whole square plus 5 times of A vector dot B vector plus 12 times of B vector modulus whole square. This is equal to 1670. Now from here we have been provided with A vector, we have been provided with B vector. So let us find out the values of A vector modulus square. So this would be 4 square, which is 16, plus 1 plus 1, which makes it 18. Let us find out the value of B vector modulus whole square. This would be 11 square, which makes it 121 plus 1 plus 1. This would be 123. And let us find out the value of A vector dot B vector. This would be 4 11s are 44 plus 1 plus 1. This makes it 46. Now let us substitute these values in this equation. So from here what do we get? Lambda to be 1670 divided by minus 2 times of 18 plus 5 times of 46 and plus 12 times of 123. And upon solving this entire equation, what are we going to get? Lambda to be equal to 1. That means we found our lambda. Our C vector is nothing but 4B vector minus A vector. We've gotten our C vector. Now what have they asked us in the question? They've asked us to find out modulus C vector whole square. So let us use the values of B vector and A vector that have been given to us in the question to find out the components of C vector. So what would be the components of C vector become? The components of C vector would become 4 times of B. That means 44. Let us do the caps one by one. 4B minus A. Sorry, this is 4B minus A. So 44 minus 4 makes it 40 I cap. For this one we have minus 4 plus 1. So this makes it minus 3 J cap. And here we would have 4 minus 1, which makes it plus 3 K cap. So this is our C vector basically. And if we were to find out C vector modulus whole square, so this would be nothing but 40 square, which makes it 1600 plus 9 plus 9, and this gives us 1618. This is our answer. So this is how we solve this type of questions. Of course, the questions that are generally asked from vectors require patience from you, because questions are very easy. The only thing is that you have to solve it very patiently, that you are soon going to reach to the answer of whatever you are trying to find out. And whenever in a question they have given you any type of equation, try to solve that equation, try to simplify it in some manner, and try to use the properties that you have studied. Based on that, you would be able to simply find out the answer. Let's look at another question. Let A vector be this, B vector be this, then the square of projection of A on B is. So first let us find out what our B vector is. B vector is equal to a vector cross I cap plus j cap cross I cap, one more cross is there, cross I cap. So first let us find the value of b one by one. So let us first find out a vector cross I cap plus j cap. So this would be equal to vector I, j cap, k cap. What are our a values? These are 2, 1, minus 1. This would become 1, 1, 0. And so what does this turn out to be? I cap times of 1 minus j cap, and this would become 0, 1 plus k cap times of 2 minus 1 makes it 1. So we have I cap minus j cap plus k cap. So after once we've found this value, now let us find out a vector cross I cap plus j cap. This entire thing now cross I cap. Let us find that value out. So from here what are we going to get? I, j, k cap. And for this value we have our vector components. So this would be 1, minus 1, 1. And here we would have 1, 0, 0. So what would this turn out to be? I cap. This would be 0 minus j cap. This would become minus 1 plus k cap, and this would become plus 1. So from here we get j cap plus k cap. Now let us find out our final cross of I cap. So we have a vector cross I cap plus j cap. This entire thing crossed with I cap. We just found this value out, and now final cross. So from here what do we get? I cap, j cap, again solving it using the determinant formula of cross, components 1. So from here we have 0. Basically we are first writing down the value of this equation, which is our j cap plus k cap. So this becomes 1, 1, and I cap is again 1, 0, 0. So from here what do we get? Our I cap to be 0 minus j cap. What is its coefficient going to be? Minus 1 plus k cap, and its coefficient is going to be 0 minus 1, so minus 1. So from here we get j cap minus k cap. So basically our b vector is nothing but j cap minus k cap. Now what do we have to find is then the square of projection of a vector on b vector. That means we have to find out projection of a vector on b vector. So what would this be written as? This can be written as a vector dot b cap, or this can be written as a vector dot b vector upon b vector modulus. So let us write this down. A vector dot b vector, our a vector, let us write it down here so that we can do the dot product. 2i cap plus j cap minus k cap. Let us do that here. Let us do the dot product here. So I cap's coefficient would become 0. From here we would have 1 plus 1 upon modulus of b vector. This becomes root under 2. So from here we get 2 by root 2, which basically is root 2. And they have asked us to find out the square of projection. So the square of projection would be root 2 whole square, which can be written as 2. So this becomes our answer. Again, as I told you, solving questions of vector requires patience from you. That is all. If patiently you could have solved this entire equation of b that was given to us, then of course your answer was very easy to find out. Let's look at the another question. Now let us look at this question. What have they told us in the question? OA is equals to a vector, OB vector is equals to 12a vector plus 4b vector, and OC is equals to b vector, where O is the origin. If S is the parallelogram with adjacent sides, then area of quadrilateral. So there has been a printing mistake. Here there would be if S is the area of parallelogram with adjacent sides OA and OC, then area of quadrilateral OABC upon area of S is equal to. So first let us draw the diagram. What have they told us? We have an origin which is O. They've told us that they've given us another point C, OC, and this is our B vector. There is another point, let's say this is our A point, and this vector is our A vector. Now this, of course, OC, and let's say this point to be my or let me draw this in a better way. Let's say this point here, this is my D. Now this basically forms a parallelogram, OA DC. So OA DC, this is my parallelogram. And how can I find out the area of this? S is the area, so it would be equal to modulus A vector cross B vector. So this is my area of parallelogram. We had studied the formula of parallelogram, right? Now they've told us that there is another point B. Now, of course, since we know that B is far more than what OD could have been, that means it is, of course, outside the parallelogram. At least we can make that out. So if it is outside the parallelogram, and if I join this, this becomes my 12a vector plus 4b vector. Now what have they told us? We have to find out the area of quadrilateral OABC. Now let's say if I join this portion as well, if I join this portion, so I have to find out the area of this quadrilateral, this entire quadrilateral. Now, of course, finding the area of an entire quadrilateral is very difficult. We do not have direct formulas for it. However, we can see that there are two triangles in this quadrilateral. One is AOB and the other one is BOC. And the adjacent sides of this triangle have been provided for both the triangles. So we can use the formula that we had studied. Area of a triangle is half A cross B, where A and B both used to be the adjacent sides. So here, from here, what are we saying? That area of quadrilateral OABC can be written as area of triangle AOB and plus area of triangle BOC. So area of triangle AOB can be written as half of A vector cross 12A vector plus 4B vector plus half of the area of triangle BOC can be written as B vector cross 12A vector plus 4B vector. Now let us try to solve this. Let us take half common from this entire equation and we would be left with the values inside. Let us take the cross product basically. So now for the first part, of course, we are going to use our distributive property here. So it would be A vector cross 12A vector plus A vector cross 4B vector and A vector cross 12A vector. Since these two are, of course, parallel to each other, basically we are talking about collinear vectors. So A vector is equal to, so this would become 0. So we can say this is simply 0 and we would be left with A vector cross 4B vector plus, and here also the same thing would happen and we would be left with B vector cross 12A vector. Now from here what we can do is we can I'm sorry, there has been a mistake here. This would not be B vector cross this value, since I hope you all remember in the first area of triangle we had written A vector cross OB vector. So here it would become OB vector cross OC vector. Of course, we have to take the first side of the triangle that has been given to us. So this would become 12A vector plus 4B vector cross B vector. So now after solving this one, we would be left with 12A vector cross B vector. Now what we can do from here is we can take 4 common. Of course, I hope you all remember the scalar multiplication of cross product that we had studied. From here what we can do is let us take 4 common from this one and we would be left with A vector cross B vector, and let us take 12 common from this cross product. We would be left with A vector cross B vector. Now let us sum this up and take the entire scalar quantities outside. So our final area of quadrilateral would come out to be 4 plus 12 would become 16 by 2, A vector cross B vector. So from here we get area of quadrilateral as 8 A vector cross B vector. And what was asked to us in the question? We had to find out area of quadrilateral OABC upon area of S. So basically our answer becomes 8 times of A vector cross B vector upon area of parallelogram. We had found out to be A vector cross B vector. So from here this gets cancelled and we get 8 as our answer. So this was again a very easy question. The only thing is that you had to understand that the parallelogram is not with the point B. Point B is somewhere outside the parallelogram, because they have given us that the point B is 12 A vector plus 4B vector. Of course, the diagonal of a parallelogram cannot be this. It would be A vector plus B vector simply, because according to the parallelogram law of addition, this value cannot be our diagonal of parallelogram. That means this is bigger than what we are expecting, so it would be outside the parallelogram, and from there basically this is how we calculate the answer. Let's look at another question. What has been given here is that A be 3 non-zero vectors such that B and C are non-collinear. Now A plus 5B is collinear with C, B plus 6C is collinear with A. Then we have to find out the value of A vector plus alpha B vector plus beta C vector. This is 0, I mean we have to find out the value of alpha and beta basically. So let us write down whatever has been given to us. We've been given that A vector plus 5B vector, this is collinear with C, so we can say this is equal to lambda C vector. And we have been given the equation that B vector plus 6C vector, this is collinear with A vector, so we can say this is mu A. Now let us eliminate A from the first equation. Let us put the value of A vector from the first equation into the other. From the first equation, what we can say that A vector is equal to lambda C vector minus 5B vector. So let us put this value in this equation. We would be left with B vector plus 6C vector is equals to lambda C vector minus 5B vector. And from here, what do we get? Sorry, this is mu times of. And so from here, what do we get? That our B vector plus 6C vector, this is equal to lambda mu C vector minus 5 mu B vector. So let us simply just, we all can see that both sides has same vector quantities, and if they are equal, that means their coefficients have to be equal. That means the coefficient of B vector would be equal and the coefficients of C vector would be equal. So let us do that. For B vector, the coefficient is 1 and that is equal to minus 5 mu. And for C vector, the coefficient is 6 on one side and the other side it's lambda mu. So let us solve this. So from here we get mu to be minus 1 by 5. And if we apply the value of mu to be minus 1 by 5, what are we getting? Lambda to be minus 30. So this is our lambda, this is our mu. So we've gotten our equations. Let us put the values in the equations. What do we get? A vector plus 5B vector is equals to minus 30 C vector. Now exactly this is what the equation has been given in the question. If you try to look at it carefully, this can be converted into A vector plus 5B vector plus 30C vector. This is equal to 0. So this is of course corresponding to this equation that we are talking about. Now here let us just simply compare the coefficients of B vector and C vector. From there we can find out the value of alpha and beta. So from here we can say that alpha would be equal to 5 and beta would be equal to 30. And upon calculating the value of alpha plus beta, what do we get our answer to be? 35. So this is our answer. Again, a very easy question. The only thing is that you must understand the property, try to substitute a few values and get the answer. Let's look at one more question. Let the position vectors of the vectors ABC of a triangle be this, this and this respectively. L1, L2, L3 be the lengths of perpendiculars drawn from orthocenter of the triangle of the sides AB, BC and CA respectively. Then L1, L2, L3 and what are the squares, sum of their squares basically. So I hope you all remember we had studied in straight line what an orthocenter used to be. and orthocenter is a point from where if I draw straight lines on the bases of the triangle, they would be perpendicular to the base of the triangle. So if let's say this was my triangle, this is my orthocenter, lines drawn from the orthocenter to the base, they would be perpendicular to the base of the triangle. So this is what my orthocenter used to be. Before that, first, since they've given us the position vectors of our triangle, let us try to draw our triangle. This is our triangle A, B and C. Now what is the A vector that they have given us? 2 I cap plus 2 j cap plus 2 k cap. So for simplicity purposes, let us just write it down as pointer format. So this would become 2 comma 2 comma 1, and also these points they've given us, these are position vectors, and we remember position vector used to be from the origin. So basically it is nothing but the point in the 3D space that we are talking about. So it can be written in any way we want. So B is 1 comma 2 comma 2 and C is our 2 comma 1 comma 2. So by just looking at these points, I think you must have noticed something, that all these 3 points have 2 2's in them and 1 1's in them. That means that this can be an equilateral triangle. So let us first find out the distance between all these 3 points. If the distance comes out to be same, that means it is an equilateral triangle. So how can we find out the distance? Using our distance formula. So let us find out our distance of AC. It is root under x2 minus x1 whole square 0, y2 minus y1 whole square 1 plus 1, so this becomes root 2. And if you try to find out BC and AB, it is also going to come the same values. So this would be equal to BC and this would be equal to AB. That means this is an equilateral triangle. This is something that we've discovered till now. And I hope you all remember, in straight line we had studied this property of equilateral triangles, that in an equilateral triangle, the orthocenter, circumcenter, incenter and the centroid all are coinciding. That means all are at the same point. That means our centroid would be equal to our orthocenter, would be equal to our circumcenter, would be equal to our incenter. We had studied this in straight line. Now here we just need to use this concept here. Now that means our orthocenter is equal to our centroid, so we can find out our orthocenter or our centroid. Let us name this G. And how do we used to find out the coordinates of centroid? It used to be x1 plus x2 plus x3 by 3. So let us do that here. From here what do we get? x1 plus x2 plus x3 by 3, we get 5 by 3 comma 5 by 3 comma 5 by 3. So this is only our orthocenter. This is only our orthocenter. Now from here what we are doing is we are drawing altitudes on the bases of this triangle. Now since this is an equilateral triangle, so of course this length is going to be equal to this. This is going to be equal to this. That means this point here is our midpoint. Let's say this is my M1, this is my M2 and this is my M3. So now we can find out our midpoints as well. And once we found out our midpoint, we know our we know our centroid or the orthocenter. So from there we can find out our distances as well. They have mentioned it in the question, right? L1, L2, L3 are the lengths of perpendicular from the orthocenter on the sides. So this is my L1, this is my L2 and this is my L3. So once we find out the distance using the distance formulas, of course our question is solved. So let us find out the midpoints first. So this midpoint would become 2 plus 2 by 2, which makes it 2 comma 3 by 2 comma 3 by 2. This point here, this would become 3 by 2 comma 3 by 2 comma 2, and this midpoint here, this would become 3 by 2 comma 2 comma 3 by 2. So we found out our midpoints as well. Now let us find out our distances. So our L1 can be written as root under distance from G to M. G to M can be written as 5 by 3 minus 2 plus 5 by 3 minus 3 by 2 whole square plus 5 by 3 minus 3 by 2 whole square. So basically this can, in a simple way, can be written as 1 by 9 plus 1 by 36 plus 1 by 36. So this becomes our L1. And now since this is an equilateral triangle, so L1 would be equal to L2 would be equal to L3. So let us find out the value of L1. What do we get from here? We get this to be root under 1 by 6. So we found out our L1, L2 and L3. And what have they asked to us in the question? We have to find out L1 square plus L2 square plus L3 square. This is what we had to find out. So simply let's just put the values. What do we get from here? 1 by 2. This becomes our answer. Again, this was the question, very easy. There were a lot of concepts of straight line used in this question. Of course, there were zero concepts of vectors basically used. They had just given us the position vectors. They were given for you to determine the points of ABC. If you would have assumed the vectors to be simply coordinates, then solving of this entire question would have been very simple. So after doing that, once you write down the points of ABC, you could have noticed that all these 3 points have almost same number of numbers. So basically there are 2 2s and 1 1s in all these 3, and they have been arranged in a different combination. That means this can be an equilateral triangle. So we do not take any risks, so we simply just calculate the distance between AC, BC and AB, and we found out that all the length of the sides were same, which was root 2. That means this was an equilateral triangle, and after we found out that this was an equilateral triangle, the entire solving of the question became very easy for us. So that was for this question, and that was all for this entire chapter. Again, it was recommended that you practice a lot of questions from this chapter, because the questions of vector basically requires a lot of practice. There would be some type of equation given to you in the question, and you would have to simplify that equation into some way so that you can get a particular value, and using that particular value your entire question would be solved. So there are 2 things that are required to solve questions of vector. Firstly is patience, and the second is practice. If you have these 2, you would be able to solve any questions of vectors. Thank you.